Good day, grade 8. I'm Ms. Babo, and today's lesson will be about the energy transfer in electrical systems. In this section, we are going to look at what current is, what batteries are, what resistance is, and how we are able to make a circuit. Let's start with what an electric circuit is. An electric circuit is a closed system where electric energy is converted to other forms of energy. Examples of that could be light energy or heat energy. An electric circuit must have the following components: a power source, a closed system, and a load. This means that there must be a complete pathway for the electricity to flow in from one terminal of the battery or cell to a device and back to the other terminal of the battery or cell. If we start to look at the components of a circuit, the first one we'll look at is a power source. A power source can either be a battery or a cell, and we measure it in voltage. If we were to ask you to draw a circuit, with a battery in, we could either ask for a cell or a battery. Batteries consist of chemicals that will react with each other, and within the battery, those chemicals are stored as potential energy. Once the circuit is open, the chemicals will react with each other to produce an electric current. The electrons collect on the one side of the battery to show us that it is the negative side of the battery. The other side of the battery that has a shortage of electrons will tell us that it is the positive side of a battery. Remember, electrons have a negative charge. So the more electrons on the one side, it shows us that it's negative, and the less electrons on the other side will show us it is positive. So if we have a look at what current is, current can be referred to as the flow of an electric charge, which is the electrons, through a certain point within a circuit. Electric current can be measured in amperes. Now, when we speak about current in electric circuits, we refer to it as conventional current. Conventional current flows from the positive side of the battery to the negative side of the battery. If you have a look at the diagram presented, the red positive signs represent metal ions and the blue little dots represent electrons. When the electric current flows through a metal conductor, which is metal, we supply it with a source of energy to complete the circuit. This means that all the electrons will move in the same general direction, and the movement of the electrons through the conducting wire is known as electric current. With regards to representing current in a circuit diagram, to show the direction, we draw an arrow pointing away from the positive terminal of the battery and an arrow pointing towards the negative terminal of a battery. This will then show the direction in which the current flows, or the flow of the electrons, and this is what we do for conventional current. If we look at what a closed pathway is, if we were to explain it, it is the conducting path that is made up of conductors. The conductor, as an example, copper wire, could be surrounded typically by an insulator, which could either be rubber, PVC, or plastic, and the reason for that is to protect us against an electric shock or to prevent a short circuit from occurring in the circuit. The symbol, if we were to ask you to draw a conducting wire, is a simple line, and as you can see in the image, those are our typical conducting wires. The difference between an open circuit and a closed circuit. An open circuit means that the current cannot flow and the pathway is disturbed, meaning that the electrical energy will not sufficiently be passed through the conducting wires as there is an opening. In a closed circuit means that the current will be able to flow through and the pathway is clear, which allows the current to flow. Now, resistance. Resistance is the opposition of a device that it has against the flow of a charge, and resistance we measure in ohms. All circuit components will offer some type of resistance, as they need to convert electrical energy into another type of energy. A device that has a low resistance means it is a good conductor of electricity, and devices that have high resistance are considered to be good insulators, as not much electricity can flow through, or electrical energy can flow through. The diagram on the right hand side shows what resistors look like, and as you can see in the cartoon, ohms represents resistance, and it creates an opposition to the flow of a charge, which is current, and that's measured in ampere. Another way in which we can explain resistance is how easy or how hard it is for electrons to move through a device. The symbols of a circuit can be represented below. If we were to ask you to draw us the circuit, these are the symbols you would use. We have an open switch, a closed switch, a cell, a battery, a lamp or a light bulb, a fuse, a voltmeter, and an ammeter. Important to remember with a voltmeter, it will always be connected in parallel to a circuit, which we teach you later on, and an ammeter will be connected in series. When we speak about energy transfers in a circuit, there are different types of energies that can be transferred in a circuit. These types of energy is electrical energy, kinetic energy, chemical potential energy, light energy, heat energy, and sound. They will all be transferred from one type of energy. For an example, if we take electrical energy can flow through a circuit to be transferred into kinetic energy. That example could be a fan, or light energy to a light bulb, or heat energy in the sense of a heater or a light bulb, and sound energy. If the electrical energy were to be transferred, it could turn to sound energy, which could produce a sound. Thank you for coming to my lesson. Our next lesson will be the effects of an electric current.